Okay, welcome to the next video, video 4.5, trying a numbering system. We'll see how that works. But this one is on calculating volumes. So recall from our video on introducing volumes to you that two dimensions multiplied by another dimension is equal to our three dimensions. Remember, I had one dimension is your regular xy, or your regular x number plane. Then you had another dimension coming in, which was your y. And then I introduced what was probably really new to all of you, this idea of a z dimension, third dimension. Okay? Oops. It's negative going backwards into the page. Okay? Right. So, right, so our area is, volume, area times the length gives our volume. So therefore, to find the area of a prism or a cylinder, so remember at the moment all you're really going to be worried about is prisms and cylinders, so don't worry about the volumes of anything crazier than that, okay? We first need to find the area of one side that is projected along a length. Remember we had that sense of here's an area, a face of a prism, and it's projected along our z dimension. Okay, so we find that area, then we multiply that area by the length, okay, of projection. So just scroll down here, and we'll see our key ideas. So first, find the area of a side that creates the prism. Okay, so some of them, let's take a rectangular prism. The side that creates the prism is this rectangle here, and then that's projected along a z dimension there. So you can kind of imagine that if we kind of did a cross section of the prism, what are we going to find? We're going to find a rectangle there. If we did a cross section here, we're going to find what? A rectangle. Okay, so that idea, this shape, this area is projected back along there. Okay, right. So a couple of examples to see how this works out. First, we have a rectangular prism. Okay, hang on, did I finish that? Firstly, find the area of a side that creates the prism, then multiply by the projection length. So you find, for this rectangular prism, we find this area and then multiply it by that z dimension that it's projected along. Okay, easy as, like really. So a couple of examples. First off, rectangular prism. Now I've put in this XYZ volume here, so these axes, just to show you how these shapes, they really do situate themselves in a three-dimensional space, okay? So, rectangular prism, I said to you before, the volume, this thing is going to be equal to the area of some side that creates the prism multiplied by the length. Okay, that it projects in the z dimension. Like, you don't have to do it as technical as this. You could just go, the volume is equal to some area of a side times the length or whatever. Okay, it doesn't really bother me. Okay, so let's have a look. Rectangular prism, it's this face here that's projected along, but really you could take this one here that's projected this way as well. It doesn't matter at all. So let's just go with this first one here that's projected in this z dimension. So area of this shape at the front is 3 centimeters times 2 centimeters times our projection length, which is 7 centimeters. Okay, 3 and 2 is 6 times 7 is 42. So I have 42 what? Units. What are we going to do? We've got centimeters times centimeters times centimeters, so it's centimeters cubed. Okay, so please remember that, centimeters cubed, okay, for volume. Right, that's rectangular prism. Cube, good old cube. Now, cube's a special sort of shape. All dimensions of this equal, so all what would you call them, side areas, which will be called something different as of next video, but all side areas are equal or equivalent. Okay, so But still, I kind of want you to think of it that we're getting this square and we're still projecting it along this length of 3, okay? So you might have seen a different formula for cube in the past, and that's fine. You can keep using that, but I want you to see it happening with this area projected in the third dimension thing, okay? So the area of our cube, okay. Why have I got area? Did I do volume before? Yeah, okay, so let's fix that. Volume, hey? Alright, the volume of this cube is equal to the area of the side that's projected times the projection length in z dimension. So we've got 3 times 3 is the area of this one here because it's a cube. So, sorry, it's square. So area of this square here is 3 times 3. I've said units are in centimeters because it's just too small. 3 times 3 times our projection length of 3. Now you might have seen this before as, I could just write this 3 cubed, okay, which is equal to 27. What are my units? Centimeters, so I'll have centimeters cubed. Wow. Holidays are getting to me, hey? 27 centimeters cubed. Right. So there's our cube. It's an easy one. So cube and rectangular prism, you might have been familiar with those before. So let's move on to the triangular prism, okay? So we've got same thing. I want to talk about the volume of this thing. Volume of the triangular prism is equal to some area of our side that's projected. Now if we can have a look what's projected in our z dimension, it is the triangle face, because if we come down here we could make another triangle, etc. Okay, so the area of a triangle face multiplied by the length that it's projected along. Okay, so what's our area of a triangle? Well, if you recall, area of a triangle is equal to half base times height, okay? So these are our 2 dimensions that we're going to try and find over here. So we have half of the base, doesn't really matter which one we take it because it's right angle, but we'll go with this one, base being 8 and height being 6. So half of 8 times 6 times our projection length of 11. So 6 8's 48, half of that's 24. Let's just sort of check that. 8 times 11. So we have 264 centimeters cubed. Okay, so seriously, all of these formulae are as simple as remembering the formula, smashing in your calculator. Okay, now in saying that, all you should need to remember is the formula for areas, okay, and just know that volume is this area projected along. Okay, right, cylinder. Wow, it's totally different to the other ones. Okay, we've got a circle now rather than one of our other more regular, easier shapes, so to speak. Okay, same thing applies. Volume of our cylinder is equal to, that's a terrible drawing of a cylinder by the way, is the area of our projected side, which is our circle, because you could come down here and draw a circle again. Area of a circle multiplied by our length in the z dimension. Area of a circle, you'll remember, is pi. Let's just put the whole thing rather than times r squared. So pi r squared times the length in this z dimension, and we're going to, then we just substitute. Okay, so r is our radius, here's our radius here, so pi times 2 squared multiplied by our z projection length, which is 7. So let's just smash that in the calculator. Pi times 4 times 7 is 87.96, so let's just make it 88 for fun. Okay, so 88 centimeters cubed. Okay, so as you can see, all of our volumes are just applied formulae, but what I want you to remember is that we've gone from this 0th dimension, right, which was just a point, then we extended it into a number line, then we extended it into a number plane, okay, my x and y lines, and then, so this is always origin, and then we grabbed this one here, multiplied it by this 3rd dimension, the z, okay, and that means that, so your volumes are going to always be, like always, the formula may change, the way that you might need to find volumes in the future might change a little bit, but it will still be, the essence of it will be the length in this x dimension multiplied by a length in the y dimension multiplied by a length in the z. So you're always going to get some length, so let's change that, some length times some length times some length for a volume. Okay, so please remember that, and the units, units are cubed. Okay, so for instance, we'll have centimeters cubed, millimeters cubed, meters cubed. Okay, so please remember that. Okay, so enjoy the video, and make sure you have a shot at some of those things and come to class with anything you don't feel like you don't understand. Okay, thanks.